Now let's look at the permission of files and directories in more detail. Um, I have a slide that explains the permission. So here's for a particular directory. If I do a long list ls-l for temp test for this particular directory, it's going to show all those information. So we have talked about the first letter in the attribute. D actually means directory, so it's telling you this is a directory. And if there's nothing, it's just a dash. If there's no letter here, then it just means it's an ordinary file. And you can also have a C, character C here, which means it's a character device. Or you can have a letter B here, which means it's a block device. Or you can have the letter L here, which means that it's a symbolic or soft link. So the first letter actually means different things for different letters. And then the rest of you have 1, 2, 3, 4, 5, 6, 7, 8, 9. You have 9 characters for the rest of the attribute column. And those 9 characters are grouped into 3 groups, and each of them has 3 letters in it. So the first 3-letter group indicates the permission for the user or owner of the file, for the user account that actually generated this particular directory or file. So it's RWX, and R means read permission, W means write permission, and X means execute permission. So for the user, the owner of the file or the directory, it has read, write, and execute permission. And then the next 3 letters actually indicates the permission of the group the user actually belongs to. So anyone who belongs to the same group as the user, whose the user account is PoChan on this particular directory, if they belong to the same group as PoChan, then it's gonna have R, W, and X. So read, write, and execute permission. So that's the group permission. That's the permission for the group. And then the last 3 letters indicates the permission for everyone else. So for everyone else who's not in the group, who's not the user, for every other user on this particular system, it's gonna R-X. So it's gonna have read permission and execute permission, but doesn't have write permission on it. So dash means no permission, no write permission here, because the dash is in the location where the W is supposed to be. So there's no write permission for everyone else, for others. So this is a directory. This is a directory. One thing that's sort of different from files for directory is that you need both the read permission and the execute permission. So R and X in order for you to list the content of a particular directory. So for everyone else, for others, you need R and X if you want if you would like other people to list the content of temp test by using ls. But for yourself, the owner, the user, and also everyone in the same group, you have read and execute permission for the directory, and also write the write permission for the directory, which means that you can add stuff, you can modify stuff inside of this directory, or change the content of this directory. We talked about the second letter, the second column, which is a number indicating how many hard links to this particular directory. Or for directory, for file, it means how many hard links, and for directory, it means how many subdirectories, including the dot and the dot directories. And then that's the user account, username, and then the group name, the size of the directory, and then the last date it was modified or created. It was modified. And here it lists several letters that are useful. So we talked about RWX. R means read, W means write, and X means execute. And then you have also several letters U, G, and O. U means user, the owner. G means group, and O means other. And all those letters are going to be useful for several commands that allow us to change permissions. chmod, chmod, the command that we use for changing the permissions of a particular file directory, uses those letters to actually make those changes. And there's also a shorthand for representing RWX permission. So the read permission has a value of 4. The write permission has a value of 2, and the execution permission has a value of 1. So for this particular example, for the user or the owner, I have R, W, and X. Then in this particular case, you can add the 3 numbers together. So read has a value of 4, 2 has a value of write has a value of 2, and execution has a value of 1. So if you add them together, it's 7. So we say that the user, the owner of this directory, has a permission that's 7. It's a number 7. It's the number 7. And then for the group, it also has R, W, and X. So it also has a permission of 7. And for others, the permission is R and X. So it's 4 plus 1. Then it's 5. So for everyone else, for others, the permission is 5. So for this particular directory, we say that its permission is 775. So now let's go back. Let's go back to the terminal and look at the particular example. So let me do a long listing of L -L, then D, because I'm listing the properties of a directory. So temp test, and that's exactly the same that's exactly the same permission that, as what we have seen on the slide. It's 7 for the user, and then 7 for the group, and then 5 for others. Suppose I want to change its permission. I can use the command called chmod. I'm gonna allow everyone else to also write to this particular directory. So I'm gonna allow others. So others is O. I'm gonna add. So add means is a plus. I'm gonna add the W permission, the write permission for temp test. Now let's do a listing of this directory. So it's RWX for the user, and then RWX7 for group, and now it's RWX7 also for others. So you can change the permission for others by just doing O plus W to add the write permission to others. Or we can do another thing that we can do is to use numbers. Suppose I would like to remove the write permission for both the group members and also others. So what I can do is I can use numbers. So read, write, and execute permission for user, that's 7. And then for group, I just want to read and execute permission, so it's 5. And then I still have others. I only want to have I want other people to have read and execute permission. So it's again, read is 4, execute is 1, it's 5. Temp test. Now do a long listing again. So now it's RWX read write permission, read write execute permission for the user. So RX is 5 for the group, and then another 5 for the user for others. So that's 2 different ways for using chmod, by using either letters or numbers. So now let's do a file. Let's touch temp test abc1, and then let's echo some commands into it. No, let's do a long listing of temp test abc1 first, because it's a file. So I did not add the option D here because I want to list the properties of a particular file. So the first letter is the first symbol is a dash. There's no letter here. It means that it's an ordinary file. And then I have RW dash for the user, and then RW dash for the group, and R dash dash for others, which means I myself can read and write this particular file, but I cannot execute it. The group members can read and write, but not execute this particular file. And everyone else, others, can only read the file. They cannot write, cannot execute this file. so let's try to echo some, do an echo a string text 1 2 3. I'm gonna put it into temp test abc1 because I have the write permission to it. So now I can change the content of this particular text file. If I do a long listing again, now the size is non-zero. Now suppose I want to remove the write permission for myself. Suppose I want to, so I can use the subtraction sign. So if you want to add some permission, you can use this plus sign. But if you want to remove a particular permission, you can use the subtract sign or minus sign. The user minus W, and then temp test abc1. Now if you do a long listing, I myself, the user, cannot write to it, but the group members still can write to it. Let's see if we can actually change the content of abc1. Suppose I want to echo a different string. Let's see what's going to happen. So it's gonna give me a error message that's permission denied. So as the owner of this particular file, it doesn't have write permission to it. So you cannot change the content of this particular file. So how do you actually make a change? You have to add the permission back, u plus w, and then you can change its content. Now if you do cat, now you can sort of see the content has changed. If you would like to use the numbers instead of the letters, you can also do that. Suppose I want to remove the read and write permission for both the group for the group members and also for others. I want to remove those. So for the user itself, I want to have read and write permission. So for the user, I want to have I would like to still keep RW permission, but for group members and everyone else, I want to remove the read write permission for the group and remove the read permission for others. And then the resulting permission, the target permission I would like to have is RW for user. That's 6 because the read permission is 4, W permission is 2. It doesn't have execute permission, so 2 plus 4 is 6. So it's 6 for the owner, and then 0 for the group member. Because I don't want group members to have read or write permissions, and I don't want others to have either read or write permissions. So it's also 0 for others. So what I can do is to chmod 600. I want permission 6 for the user, permission 0 for the group, and then permission 0 for others. Now if I do a long listing, there's only RW for the user, and then no permissions for anyone else. If you would like to change the owner of a particular file, for now this temp test abc1 has an owner that's PoChan, and then there's the group name is also PoChan. If you would like to change the owner or change the group to a different owner or group, you can use the command ch. If you want to change the owner, it's ch own own. Suppose you want to change the particular file, this file, to a different user. Suppose I have a different user. There's a different user account on this machine called Xiaojia. If you would like to change it to this particular user, to this particular owner, you can do cho followed by the other username and then the file name. And then it's gonna have permission problems because you are not the super user. So in this case, you can do sudo. Sudo will allow you to change the permission, but it's gonna ask you for the password. And then if you do a long listing of ABC1, then the owner has been changed to this new user ID, user account. You can also change the group by using chgrp, and then you can change it to some other group. Suppose I have a group that's called wheel, and then followed by the name of the file. But again, I have to use sudo here. So if you do a long listing now, so the group name has been changed. And you can also use the chown to actually change the group and the owner simultaneously. So you have to use that's the owner followed by colon and then followed by the group. Now if you do a long listing, it's gonna change the permission, change the owner and the group back to its original state. So don't forget about the colon here. So you can use chown to change the permission, to change the owner and the group simultaneously in just one command by separating the owner from the group with a colon. The chmod command also has several options that are quite useful. One of the options is called a reference. So let's try to generate a few more empty files by using touch. I'm going to do test abc2 and then touch. So if I take a long list of, it's going to give me three files. Suppose I would like to change my permission for ABC2 and ABC3 to exactly the same as ABC1. I can then use ABC1 as the reference, and then I can do chmod -- reference followed by the file that I want to use as a template, and then followed by the files that I would like to change the permission. So those are temp test. So ABC3, ABC star. I'm going to use the wildcard. So in this particular command, I'm using temp test ABC1 as a template. I want the files, all the files on the temp test, starting with ABC, to have exactly the same permission as ABC1. Of course, this wildcard actually includes ABC1, but because ABC1 already matches the permission of itself, so chmod is not going to change the permission of ABC1, but it's going to change the ABC2 and ABC3 to exactly the same permission as ABC1. So now if I do a long listing, as you can see, it's the permission of ABC2 and ABC3 has changed to RW for the user, and then 0 permissions for every for the group and others. And there's also a quite useful option that's -r. So if I do a long listing for the temp directory, it shows me it's a drw, it's a d rwx, it's a 775. So the temp directory has a 775 permission. So if I want to change the permission of temp, and also it's a subdirectory test. So the test subdirectory has 7 and then 5 permission. So if I want to change, let me try to generate a few more directories. So here I'm generating test1 and test2. So test2 is the subdirectory of test1, and then test1 is the subdirectory of test. And then we can look at, so test1 has a permission that's 775, and then test2 has a permission that's 775 also. So if I want to change the permission of temp and all its subdirectories, all its nested subdirectories, to the permission 755, I can use the chmod -r, the recursive, big R, capital R, means recursive, and then followed by the permission that I want to use, and then temp. Now it's gonna change the permission of temp and all its subdirectories to have the permission 755. So if I want to look at test2, and you can see it has changed. from 775 to 755 actually. If you look at the test 1, it also has a 755. Test has 755 at the beginning, but temp should have 755 now. So that's dash R recursive and a dash dash reference. That's using a particular file as the reference for changing the permission of other files. Now let's look at the du command. Du represents the disk usage. It allows you to count the amount of disk space a particular file or directory is occupying. So if you just type du under the home directory, then it's gonna list the space each directory and its subdirectory is occupying on the disk under my home directory. That's gonna be a lot of files, and I won't be able to see them because it's gonna scroll through this entire terminal screen very quickly, so I won't be able to read it. Let's try the du command inside of the temp directory that I have created before. So if you do du under the temp directory, it's gonna list all its subdirectories and the space that it's occupying. On the temp, I also have several files actually. On the temp test, I also have several individual files. So if you would like to print out the disk space of individual files in addition to all the directions and directories and subdirectories, you can use the -A option. And then it's going to print out the space different files are occupying and also the different directories are occupying. So here's for individual file, here's another individual file, and then that's another individual file. And these are directories and subdirectories of temp and the test. And the numbers that's printed in the front is the disk space in bytes. But if you want to use a human readable format, you can use a -H. -H means human readable, or you can just combine A and H together. Then it's going to print out the units of the storage. So it's 4 kilobytes, 8 kilobytes, 4 kilobytes, 16 kilobytes, and total is 20 kilobytes. So now it's now there's also a quite useful option, that's C. Then the C option is going to give you some kind of summary for the entire directory at the end of the printout. So it's giving you quite a nice summary. It's telling you 20 kilobytes total. And you can also exclude a certain file pattern from the counting. Suppose I want to exclude, for example, ABC2 and ABC3, these two files from the counting. I can use the exclude option, and exclude is followed by the equal sign, and then the pattern of the particular file name. So I'm going to use a wildcard. I'm going to use a suppose I want to exclude ABC2, just ABC2. Now you see ABC1 and ABC3, but you don't see ABC2 anymore. And I can sort of use multiple exclude. I want to exclude ABC3 also. And then now if I want to exclude ABC1, because ABC2 and ABC3 has a size of 0, so excluding ABC2 and 3 doesn't change the total size. But ABC1 actually has a size of 4K. So if I exclude ABC1, the total size is going to reduce to like 16K. And you can combine those 3 excludes into like 1 exclude. By using a wildcard. Now it's the total size is 16K, and you can actually put those exclude into a text file. Suppose you want to exclude just ABC2 and ABC3. So if if I put the files that I want to exclude from, or the file patterns that I want to exclude into a text file called exclude.txt, um, suppose how I can generate this particular file by using this echo. Here I'm using a -e because there's a escape symbol inside of the inside of the string sequence. So \n actually means return or a new line sign. I want to put ABC2 and ABC3 on two different lines as shown here. So if you want to include a escape characters into the sequence, you have to use the -e option to make it into a so the text file is going to be separated into two different lines, and then you can just use du dash big capital A case X followed by the file name. That's exclude.txt, and then you can just use your ordinary options. That's AHC, I think. Then it's gonna exclude ABC2 and ABC3, but it's gonna include ABC1, and it's actually using this particular file to actually exclude the file patterns that you don't want to include in your disk usage count. Now let's try to search for certain files that match some criteria that you specify. And the command for doing that is called find, F-I-N-D, find. So you can use this command to find specific files that match the criterion that is specified. Let's try to generate some artificial files first. Let's use temp test, and then let me try to touch some empty files. ABC temp test, ABC1, temp test, ABC2, temp test, ABC3. So now I have a bunch of files that's under temp test. All of them are empty. It has a size 0, ABC1, 2, and 3. So suppose I want to find those files that starts with ABC. I want to find all the files that starts with ABC. I can use the command find, and then just follow with option name, and then followed by a text string that matches a certain pattern of the file name. So I'm gonna match everything with starts with ABC and then followed by one letter or one character, and let's see if we can find it. So it finds temp test ABC 1, 2, and 3 right away, and then the prompt keeps blinking, and it looks like it's hanging. The terminal is hanging. The reason is that you did not specify the entire. Oh, okay, now it has finished. So the reason that it was so slow is because it's actually searching through all the files under your home directory to see if there's any match to this particular file name pattern. And that's a lot of files that you have to search. So if you have some idea about where the files might be, you can give it some idea. You can give it some directory to search for. So suppose I want to search on the temp, and then name ABC question mark. I can also use star if I want to match all the file names that starts with ABC and then followed by 0 or any number of characters. This time it's a lot quicker. So because you have asked find to just search inside of the temp directory, and then it finds all the files right away. So you can use the you can give the find command a specific location to search for. There's another option that's quite useful for find. Suppose you would like to find all the files starting with the name ABC and then with the size that's larger than 0 kilobytes. In this case, you can do find temp name starts with ABC followed by star, so 0 or a number of characters, and then you can use the size option. The size option allows you to specify the size number the size of the files. So if you do plus 0k, for example, then it's gonna search for files that's with a size that's larger than 0. For now, we have 3 files: A, B, C, 1, 2, and 3. That's on the temp test. But all of them have a size of 0. So let's try to echo a command, echo some text into one of the files. Test 1, 2, 3, and then I'm going to echo it into temp test ABC1. So now if I do a long list temp test, it shows that ABC1 has a size that's larger than 0, and then ABC2 and 3 are uh, 0 size. So if I do find temp dash name ABC star, it's gonna search for all the files with their names starting with ABC, and then with size that's larger than 0k. So this time it's gonna give me just the one file, that's ABC1, because this is the only file that matches this particular condition on the temp. So that's the size option. You can also use the size option in the opposite way. So if you want to find all the files that has a size that's exactly 0k, you remove the plus sign, and then it's gonna find the other two files whose size are exactly 0. And if you would like to find files that's smaller than a particular size, for example, uh, smaller than 10k, for example, if you would like to find all the files that's smaller than 10k, then you put a minus sign in front of the size that you specify. So this time it's going to find all the 3 files because all of them actually has a size that's smaller than 10 kilobytes. So you can use the size to specify the file size that you like to find. And then there's um, another option that's called user dash user. It will allow you to find the files with a specified user. So it's called user. So if I want to find the files that belongs to the user PoChain, I can use it like this. It's gonna find all the files that belongs to PoChain and matches all the other conditions. Now suppose I change the owner. If I change the owner of ABC2 to a different user, for example, I'm gonna do sudo on temp test. No, I'm gonna use a new user, and then temp test ABC2, for example. Now if I do a long listing, now ABC2 actually belongs to a different user, Xiaojia. So if I want to find the files that starts with ABC star and then smaller than 10 kilobytes, and the user is PoChain, it's just going to return ABC1 and ABC3, because ABC2, for ABC2 the user is not PoChain. So you can search for files that belongs to a particular user by using the dash user option with the find. And um, if you would like to search for a file that search for files that do not belong to a particular user, for example, do not belong to PoChain, you can use another option called not. So the not option will negate whatever condition that follows the not option. So in this case, it's going to search for files that do not belong to this particular user PoChain, and then it's going to return ABC2. It does not belong to PoChain, so it belongs to Xiaojia. So you can actually use the not in front of any of the conditions that we have used so far. So you can also put a not in front of the size option, for example. So in this case, it's going to find files with a size that's not smaller than 10 kilobyte. So it's larger than or equal to 10 kilobyte. In this case, it's not going to find anything because all the files have a size that's smaller than 10 kilobytes. And that's the not option. It's it will cancel out whatever condition that you specify or whatever criterion that you specify after the not option. The find command has many options. One more option that might be useful is the Perm option, which allows you to search for particular files with a given permission. So you can search for files, for example, with just the read and write permission for the user, that kind of thing. But how to use this option is slightly more complicated. So I won't talk about the details here. And one more thing that's quite useful is that the search results, the results of the find command can be used as input for executing a certain other command. And for example, let's look at the long listing of temp test, the files underneath it. Suppose I would like to add the write permission for others for ABC1 and ABC3. The two files that belongs to this username progen. So if I would like to combine the find command with a chmod, change the add the write permission for ABC1 and ABC3, I can do this. I can find temp name ABC star, and then user, because I'm only interested in the files that belongs to this particular username, and then maybe specify a size less than 10K, for example. Um, there's the option for executing a particular command is called exec, and then the command that we would like to use is chmod o plus r. So we're gonna apply the chmod o plus r, means other, no, o plus w, I think. I would allow other people to write to this particular file. So change the permission, add the w permission for o, and then the next sequence is quite important. You have to use the curly braces, left and right curly braces, one next to each other, and then space, and then backslash, and then semicolon. So this exec option allows you to execute a certain command, and this curly braces is actually where you would like to put the output of the find command. So suppose you don't have this -exec option, and then find is gonna print out find some of the files that you are looking for that satisfy all those criteria. The name starts with ABC, user is progen, size less than 10K. So it's gonna give you a sequence of file names. But where do you want those file names to go for the command that's after the exec option is indicated by this pair of curly braces, and then backslash semicolon is just a way to tell find that this is the end of this particular command, this chmod command. So you can put any kind of command after exec, but you have to end that particular command with a backslash and a semicolon. So now let's look at what's going to happen if we do ls temp test, and you can sort of see the two files that belongs to progen actually has w permission for o now. So the others have write permission now. Another command that allows you to find stuff is the grep command. The grep command allows you to search for files that contains a specified string of characters. So if you grep, for example, test, and then specify the files, and then it's gonna look into all the files that's under temp test, and it's gonna look into all the files that's under temp test and find those files that contain a string that's test. So if you do that, it's gonna print out the file name first, which is temp test abc1, and then followed by the line that contains this particular this particular sequence of strings. So basically that's the basic usage of grep. It allows you to search for a particular sequence of strings in a set of files. And you have some other options. For example, it has quite useful options. Suppose you would like to number the lines, for example. So here it's added one more number. It's telling you it's a 1. So it's actually on the first line. So to make the examples sort of more interesting, we can try to construct some slightly more complicated text. Suppose I wanna let me just try to so on the temp test I have 3 files, right? If I do a long listing, let's try to echo some more stuff into ABC1. So I'm gonna do test 4, 5, 6 for example, and then I'm gonna append it into temp test ABC1 for example. So we looked at this the larger design, which is basically overwrite stuff to a particular text file. So this larger than design actually is a redirection that allows you to append stuff to the end of the previous file, to the end of this file. So if you do that, and then if you do cat temp test abc1, it's gonna have 2 lines, right? And then let's try to add some more stuff, slightly more interesting stuff. So suppose let's do a cat cat 10. Let's just put it in a temp abc, for example 4, and then let's echo hat 5. So put it in temp abc 5 for example. So now we have some more files that we can play with. So now let's give it a try. Let's give it a try. See if we can actually do some more complicated stuff with grep. I showed you the n option, right? So you can use a grep n. For example, temp test star to number all the different lines that contains the test in a particular file. And also you can use the color, so it's gonna highlight the occurrences of the particular string that you are looking for. So grep-n allows you to number it. So the number here is displayed in green now, and then the occurrences of this particular search pattern is now highlighted in red now. So that's the -n and dash color, these 2 options. And then it also allows you to search for specific patterns. For example, suppose you would like to search for CHAT, for example. So temp star. So what does this command mean? It means that it's gonna you want to search for the string that's either CAT or HAT. You want to search for the string either cat or hat on all the files in all the files on temp. So this time it's gonna print out this particular line because temp abc4 has 1 line that's cat 10, so it was able to match C. But in this command, we also generated another file that's called abc5, temp abc5. If we look into the content abc5, you're going to see there's a hat file, but the hat h is actually in capital letters. So it's a big case. But when you did the search, it was small case c and small case h. So it's going to look for either small case cat or small case hat. If you want to make it a case insensitive, you can use the -i option to make the case insensitive. or you can just combine -i with -in. So now it's gonna print out the both so ABC1 has the first line has a cat 10, and then ABC5 has another line that's hat 5. So basically that's a -i option that allows you to do this kind of thing. And then another thing that you might have noticed is that it's telling you that temp test is a directory. So by default, it's not going to descend into the subdirectories. So if you would like to if you would like grep to descend into all the subdirectories inside the directory to look for files that contain a certain sequence of string, there's an option that's R. So it's gonna so if you do -i-n R means recursive, then it's gonna descend into the test subdirectory of temp to look for files that contain cat or hat. In this case, if you have the -r option in it, it's not going to report that temp test is a directory, but it's not going to be able to find additional files that contain cat or hat, because the temp test subdirectory has three files. Two of them are empty. The other one, ABC1, doesn't have any strings that contain cat or hat. But suppose if you change the search pattern to, for example, test, then it will be able to find ABC1. It's going to print out this particular string. There's another option that's quite useful. It's the -v option. Suppose you would like to search for the lines that does not contain, for example, 1, 2, 3. If you would like to search for so V actually means invert. You invert the search. So you would like to search for files underneath temp recursively, because you have -r, that does not contain a line that has 1, 2, 3, this particular string pattern in it. So ABC4 and ABC5 underneath temp do not have 1, 2, 3 in it. And then ABC1 has two lines, right? ABC1 has two lines. If I do cat temp test ABC1, it has two lines. One of the lines the first line has 1, 2, 3 in it, but the second line do not have it. So it's also going to print out the second line, the line that does not have 1, 2, 3 in it. So -v actually allows you to invert the search. So the grep is actually a quite useful command for you to look for files that contain important sequence of strings. One more option that might be useful is the -l option. So in this particular command, we were able to find like two lines inside of the same file that has the string test. So if I just repeat this command, it's because it has two lines that has the string test in it, so it's gonna print like two lines. The two lines are for the same file actually. So if you would like to just see the file name that contains a particular string, you can use the option that's L. In this case, it's just gonna print out the file name. So it doesn't matter how many occurrences of this particular string actually happens in this particular file. It's just gonna print out this file just once. And there's another option that's quite useful. It's called it's -c. It's -c. C is gonna print out the occurrences, the number of occurrences. So it's gonna search through all the files, and then it's gonna print out the number of occurrences of this particular string character, this string inside of each file. So if a particular file doesn't have any occurrences, it's gonna print out a 0. You see, and then for ABC1 it has two occurrences of the same string test, then it's gonna print out 2 after the file name. So this little L option allows you to just print out the file names of the files that contain a particular search pattern. If in this case I'm doing a recursive search underneath temp, so I'm gonna search through all the subdirectories of temp. I'm gonna ignore cases for the search pattern, and then it's gonna just print out the file that contains this particular search pattern, the file name of the file that contains the search pattern. If I want to look at the content of ABC1, it actually has 2 occurrences of the search pattern test. So, um, so if you would like to reverse the effect, if you would like to list the file names of the files that do not contain a certain search pattern, you can use the big L. The big L, the capital case L, actually is the sort of the opposite of the little case L. So it's gonna print out the file names that do not have any occurrences of the search pattern. So in this case, it's gonna print out 4, 5, ABC2, and 3. So if I do a long listing of temp test ABC2, temp test ABC3, both the files are empty. These are doesn't have any content in it. These 2 files do not have any content in it. So that's why it's actually grep is printing their file names, because empty files do not have this search pattern in it. And then temp ABC4 and temp ABC5, that's because temp ABC4 has the text cat10 in it. It doesn't have any occurrences of test. That's the search pattern. Right? It doesn't have any occurrences of the test search pattern. And then 5 is hat5. It doesn't have any occurrences of test in it either. So that's why it's actually printing out all those files that do not have. grep is actually printing out the file names of the files that do not have this particular search pattern. So small L and big L, they are sort of the opposite senses of search.